In the constellation Libra, 190 light-years from Earth, there exists something that defies everything we thought we knew about the universe. A star, so ancient, so impossible, that its very existence rewrites the story of cosmic creation. This is the tale of a stellar rebel that shouldn't be here, and yet it burns brighter than ever, holding secrets that could unlock the mysteries of our universe's birth. It was 2005 when astronomers first turned their instruments toward what they assumed would be just another ordinary star. But the moment they analyzed its light signature, everything changed. This wasn't just any star. This was HD 140283, a celestial time capsule that seemed to predate the universe itself. Imagine discovering a book written before paper was invented, or finding a photograph taken before cameras existed. That's exactly the kind of cosmic impossibility we're dealing with here. The star's spectral analysis revealed something that made scientists question their fundamental understanding of stellar evolution and cosmic chronology. Initial calculations suggested this star was approximately 16 billion years old. But here's where things get mind-bending. Our universe is only 13.8 billion years old. How can something exist that's older than existence itself? It's like finding your great-grandfather's birth certificate dated before the invention of time. This astronomical paradox sent shockwaves through the scientific community. Some researchers nicknamed it the Methuselah star, after the biblical figure known for his extraordinary longevity. But unlike mythology, this was cold, hard scientific data that demanded explanation. The implications were staggering. Either our understanding of stellar aging was fundamentally flawed, or our calculations of the universe's age needed serious revision. To understand why this star breaks all the rules, we need to dive into stellar archaeology. Every star carries within its light a complete genetic code, a stellar DNA that tells the story of its birth, its journey through space, and the cosmic environment it formed in. When astronomers decode this information, they're essentially performing an autopsy on starlight that's traveled across the galaxy for millions of years. HD 140283 stellar DNA reveals something extraordinary. It has virtually no heavy elements, what astronomers call metals. In the cosmic sense, everything heavier than hydrogen and helium is considered a metal, from carbon and oxygen to iron and gold. This star's composition is almost pristine, containing less than 1% of the heavy elements found in our sun. This is the smoking gun that reveals its true age and origin. But why does the absence of heavy elements matter so much? The answer lies in understanding how the universe evolved. In the beginning, there were no heavy elements at all. The Big Bang only created hydrogen, helium, and trace amounts of lithium. Every other element in the periodic table was forged inside the cores of massive stars and scattered across space when those stars exploded as supernovas. Each generation of stars that formed afterwards inherited more and more of these heavy elements. It's like cosmic evolution. The universe gets more complex with each stellar generation. HD 140283's Extreme metal deficiency means it formed when the universe was still in its cosmic infancy. It's a survivor from the first generation of stars, a witness to the universe's childhood that somehow managed to avoid destruction for over 13 billion years. The existence of HD 140283 forced astronomers to confront an uncomfortable truth. Either this star was somehow older than the universe itself, or our fundamental understanding of cosmic chronology needed urgent revision. For decades, scientists have used multiple independent methods to calculate the universe's age, from studying the cosmic microwave background radiation to measuring the expansion rate of space itself. All these methods converged on approximately 13.8 billion years. But here was a star that seemed to mock these calculations. The implications were staggering. If stars could exist before the Big Bang, it would overturn everything we thought we knew about reality. Alternatively, if our age calculations were wrong, it meant our understanding of fundamental physics might be flawed. This wasn't just an astronomical curiosity, it was a potential crisis that threatened the very foundations of cosmology. Faced with this cosmic conundrum, astronomers did what they do best. They looked deeper. Using more sophisticated instruments and refined techniques, they began re-examining every aspect of HD 140283's properties. The Hubble Space Telescope was enlisted to measure the star's distance with unprecedented precision. Ground-based observatories analyzed its brightness fluctuations. Computer models simulated its entire evolutionary history. Slowly, painstakingly, a clearer picture began to emerge. The refined measurements reveal that while the star was indeed ancient, possibly 13.2 billion years old, it wasn't quite as old as initially calculated. The margin of error in the measurements meant it could be anywhere from 12.8 to 13.6 billion years old. This brought it just within the realm of possibility, making it old enough to be among the universe's first stellar citizens, but young enough to actually exist within our cosmic timeline. Even with its age refined to fit within cosmic possibility, HD 140283 remains one of the most extraordinary objects in our galaxy. This star has witnessed events that we can only dream of understanding. It was shining when the first galaxies were still forming. It watched as the universe transformed from a dark, simple place into the complex, vibrant cosmos we see today. Imagine the stories this star could tell. It has survived galactic mergers, close encounters with black holes, and the explosive deaths of countless neighboring stars. HD 140283's journey through space reveals another fascinating aspect of its character. This isn't a typical star following a circular orbit around our galaxy's center. Instead, it's what astronomers call a halo star, part of a sparse population that follows highly elongated eccentric paths. Its orbit takes it far above and below the galactic's disk, reaching distances of up to 60,000 light-years from the galactic center. This unusual trajectory is actually key evidence of its ancient origins. Early stars formed before our galaxy had settled into its current flat, rotating disk structure. They retained the chaotic orbital patterns from the universe's youth, when galaxy formation was still a work in progress. HD 140283 is like a time capsule in motion, carrying within its trajectory the memory of our galaxy's violent birth. Every 40 million years or so, it completes another lap around the Milky Way, a cosmic marathon that it's been running for over 300 complete circuits. The study of HD 140283 has revolutionized our understanding of the early universe. It's provided crucial insights into how the first stars formed and evolved. More importantly, it's helped astronomers refine their models of cosmic chronology and stellar evolution. This single star has contributed to more accurate calculations of the universe's age and the timeline of cosmic events. But HD 140283 isn't just a historical curiosity. It's a key that unlocks secrets about our own cosmic origins. The elements that make up our bodies, our planet, and everything we see around us were forged in stars like this one. By studying these ancient survivors, we're essentially tracing our own family tree back to the universe's childhood. It's humbling to realize that the carbon in our DNA, the calcium in our bones, and the iron in our blood all have cosmic origins that can be traced through stars like HD 140283. HD 140283 has inspired a new field of astronomical research, the hunt for other ancient survivors. Astronomers now actively search for similar metal-poor stars that might provide additional clues about the early universe. Each discovery helps piece together the cosmic puzzle of how we got from the simple, dark universe of the Big Bang's aftermath to the rich, complex cosmos we inhabit today. Some researchers believe we might find stars that are even older, pushing the boundaries of what we thought possible. Others are using these ancient stars to test theories about dark matter, cosmic inflation, and the fundamental forces that shaped our universe. The implications extend beyond astronomy into particle physics, cosmology, and our understanding of the very nature of reality. HD 140283 reminds us that the universe is still full of surprises, and that sometimes the most profound discoveries come from the most unlikely places. HD 143283, the star that shouldn't exist, continues to shine in the constellation Libra, a cosmic lighthouse that has guided humanity to a deeper understanding of our universe's history. Its story reminds us that science is not about having all the answers, but about asking better questions. Sometimes the greatest discoveries come from things that challenge what we think we know. This ancient star, older than most of the galaxy, proves that the universe is far more mysterious and wonderful than we ever imagined. And somewhere out there in the vast expanse of space, other impossible stars are waiting to tell their stories. The next cosmic mystery is just a telescope observation away.